Hello and welcome to HUPS third interview with Dr Roediger.
Oh,
Hello.
nice
How
to
are
be
you?
here. Thank you. I'm doing all
Um,
right. How are you?
I'm doing all right. So let's get into it. So what got you into physics?
I think I liked physics from a pretty young age on, and somehow space flight I found very interesting, and I was intrigued by those people who had been in space and where I grew up. The first cosmonauts were big heroes, and I thought this would be so cool if I could see the Earth from above, and also learning about planets and things beyond. You know, thinking back, without having been able to phrase it that way at the age of 6, but I think what, really fascinated me is that we can understand stuff we can't even touch.
Ah,
Things that are so far away and we can still understand them and somehow connect to them. I couldn't have said this when I was 6, but I think that was part of it. Yeah, so I wanted to be a cosmonaut when I was a kid.
so you decided physics was the best option for becoming a cosmonaut? Or
Um, Kind of. I think when I was in the teenage years, I realized that it's maybe not 1 in a million chance, but 1 in 10,000 or so to
Hmm.
actually fly to space. And that probably what I envisioned is studying or understanding the things that are out there. And physics was the right track for doing that. I also thought, well, actually, back then, when I went to university, the people around me and even the people at my fellow students at university, we all studied physics because we liked it for some reason. When we were in our first year, we were joking that when we were done, we would all be driving cabs. We truly believed for the first year or so that we probably wouldn't get a decent job because, I mean, what do you do as a physicist, right? Nobody knew a physicist who had a job. But it turns out that there was a huge misconception. So everybody who finished their degree got a pretty nice job. And so we studied physics, and astrophysics seemed even more extravagant. And so I went for physics rather astrophysics, and specialized in astrophysics in my final years. And yeah, that's why I ended in as a physicist according to my degree certificate.
Right. So it was at uni that you really pushed into astro and just in the
Um,
final
I,
year?
I, I always wanted to do that and specialize, at least do a little bit more in that.
Yes.
And so I chose a university where I could study physics and would come out as a physicist, but had the option, if a few
Ah,
years down the road, I would still like doing
yeah.
astrophysics. And it all worked out. So I've realized I've been earning money as an astrophysicist for almost 20 years.
Wow.
Right? So I have those under my belt.
So which university did you end up going to? Just
It was the University of Kiel in Germany.
right.
That's north of Hamburg. So I think the Kiel Canal is a term in English. The canal that connects the North Sea and the Baltic Sea.
Hmm.
And at the Baltic Sea end is the city of Kiel, and that has a university and that had a small astro department. And so I studied there and did my astrophysics lectures with the professors from that department, and that's where I also did my PhD eventually.
All right. So what did you do for your PhD? What was
Um,
focused on?
so I didn't do all my undergrad years in Kiel. At that time, doing physics meant a 5-year degree. There were 2 years of lectures, and then we had a set of 4 oral exams. That was the former rule. That it was the intermediate stage. We actually could replace one of them with the one written exam we had done up to this point. And there were 2 more years of lectures and labs and tutorials. There were another 4 oral exams. And then we had 1 year of full-time research, pretty much like today here in Hull and MSc by research would be. And so that would have been the normal track, and I swapped the last 2 years. And for the research project, I went to Glasgow first, and then I came back to Kiel in Germany and thought, Germany can be bureaucratic as well, same as the UK. And I thought, well, let's not take chances. Let's get a German degree as well as the Scottish one. And so I finished my what is called diploma in Germany, and then I did my PhD in the same department, and that was on numerical simulations of galaxies and galaxy clusters. So the title was something with RAM pressure stripping of disk galaxies.
Do you have an example of that?
So thinking back, the funny thing is, I could summarize all I've done in my research life as I've been simulating things falling into galaxy clusters. So a galaxy cluster is a collection of galaxies held together by gravity, and it's called galaxy cluster because first astronomers observed the optical, and they noticed on the sky that there are crowded areas where there are galaxies. That is how they showed up when we looked first. Actually, the galaxies form only a very small part of the clusters. As almost anywhere in the universe, dark matter is the dominant component, and the galaxies aren't even next after the dark matter, but the dark matter creates a gravitational potential well, and the random gas in the universe settles into those potential wells. And there's a lot more gas outside of galaxies than inside galaxies. And that gas accumulates onto the clusters and forms like an atmosphere of the cluster. And we call this the intra-cluster medium, and that's where the bulk of the normal material is. Right? So we have a gravitational potential well filled with a hot atmosphere, and the galaxies are zooming around. So if you think from the perspective of a galaxy's life, it's flying through an atmosphere at supersonic speeds most of its life. So it's experiencing a pretty strong headwind, and that's strong enough to strip off its own gas. Wow. And that's what I've been simulating.
Wow.
Right. So it's like when you go very fast on a bike or so, or stick your head out of a car, the hair blows back. And it's the same physics that's happening to the galaxies. And it's a relevant process because if you maybe remember back from your first year, the astronomy lecture, the stars and the galaxies form out of the gas between the stars. But if that gas is gone, no new stars form. So whether a galaxy has gas in it or not determines whether it's let's call it alive or not, whether it can form new stars or not. And so if all this model is true, then of course it would mean that galaxies and clusters should have lost a lot of their gas or even all of their gas and would stop forming stars.
Nice.
And it's yet an quite easily observable effect because stars who are short-lived are blue. And if no new stars form, then the blue stars who don't live long die young. So they always die young, so they just die. And then there are no blue stars left in the galaxy and they turn red. And it's an observable effect that inside clusters, galaxies are redder than outside of galaxy clusters. And we can even detect the gas and see that the gas is gone.
So the galaxies die quicker when they're in these clusters.
Exactly.
Right.
Exactly. Right. And then you can, play variations of the game, and instead of throwing a disk galaxy with a gas disk into a cluster, you can take a roundish galaxy which has a roundish atmosphere of its own and see what's happening. Or you can make the thing that falls in a bit bigger and say, I'm taking a little galaxy cluster which is called the galaxy group and have it fall in. Or I take two galaxy clusters and smash them together. And
And
that,
this is all done with numerical simulation.
yeah, so there are many people who do observations of these topics, but I somehow ended up in the simulation business, and I'm doing the simulation side of things.
And so that's what you're continuing to do to this day?
Yes, we're still doing this. Yeah, so all the PhD students and project students who are working with me have worked somehow in this area.
So they're doing similar things to what you did when you did your PhD?
So I've moved, well, temporarily I had moved away from the disk galaxies and focused more on elliptic galaxies and small clusters falling into bigger clusters. But I've revived the disk galaxy business a few years ago, so I have a postdoc working with me on that. And also a current PhD student is working on a related topic. And the PhD student doesn't follow the disk galaxies in detail, more like working out what's happening to galaxies, to disk galaxies in a cluster or in the cluster while it's merging with another cluster. So we're adding complexity and starting and studying different aspects of the same topic.
Ah.
You know, have you seen pictures of Jupiter? There's these bands along its atmosphere and these little wiggles along the atmosphere. These are effects where layers of gas are slipping over each other, and they are prone to interesting instabilities. Some of them are called Kelvin-Helmholtz instability. And I don't know, maybe you have done some numerical experiments in your second year labs. Maybe not, maybe it was the year before you or so.
Yeah.
Yeah. And they form kind of roll-like features, like a kid might draw waves. And if you know what to look for, you can see them along the edges of clouds as well. And the fun thing about and the mind-blowing thing about physics is it works everywhere. And we start seeing these roll-like features in galaxy clusters. And we can see them in the simulations. And several years ago, maybe almost 10 years ago, I started working quite closely with observers. And there was this key moment where an observer showed me a picture and said, yeah, look at these features and these funny horns here. Well, we never see them in the simulations. And I went, hang on, I see them all the time. And that clicked. And I'm still working with this group of researchers from the Center of Astrophysics in I think the full name is Harvard-Smithsonian Center for Astrophysics. So it's in Cambridge in the US. And they're X-ray observers. I do the simulations, and we've done some pretty cool stuff.
So it's the combining of two sides of astrophysics being pulled together and just finding some really interesting stuff.
Yeah.
Cool. Right. And I know you've done some conferences around and places like that. So is this the sort of stuff that you end up doing at these conferences?
Yeah, the conferences are a key part of how the science community, or at least definitely the physics community, but definitely the astrophysics community, how we communicate. And there are pots of money from the research institutes, or sometimes there's a rich university who can run a conference, and it's announced, and then you can apply to give a talk or make a poster, show a poster there. And then there's usually a scientific organizing committee who read all the applications for the people who want to give a presentation, who want to give a talk. And you usually submit a 200-word, 100-word abstract. And based on that, they select who's giving the talks. Usually they try to have some invited talks or review talks as well, where they try to select the experienced experts in the field to talk about, either give a review or talk about their research without them needing to apply to give a talk. I haven't seen it very often that you get paid to go, or that you even get covered that the costs get covered. So if I go to a conference, even if I'm an invited speaker, usually I have to pay this from my own research grants. So it's not my personal money, but either the university or research grant needs to pay for that. And then, yeah, we hang out in a conference room for a whole week, or maybe sometimes only 3 days. And it might sound like exotic places, but quite often, for the bulk of the time, we are in a windowless room talking science. Right? And one person after the other gives their talk. Usually it's something like 10 or 15 minutes. And then there's depending on how tight the schedule is, there are 2 minutes for questions, maybe 5 minutes for questions that you get from the audience and you try to answer. And if you're going down, or somebody seeing this is going down the research route, when I was young, I thought that's the main bit. But the actual things, the actual discussions are happening during the coffee breaks. You go and talk to the person who gave that interesting talk and who made this weird statement. We thought, hang on, I need to ask them about it. And there you make the connections, you can have the more in-depth discussion, and then you go to lunch together, you go for dinner together, and sometimes it meanders off research and then it goes back onto the research. And it ends up being a community of people, where the young people come in, many of them leave, of course, because not everybody who does a PhD ends up in research. But over the years, there's sort of a community of people who keeps in the same field. And that's quite nice to see them once in a while as well.
So would you say that, I don't want to use the word networking, but is that like the main part? Yeah.
Yes. Well, there are other ways to network too, but conferences are definitely a good place to do that.
Nice.
Yeah, and definitely go to the coffee breaks and the lunches and the dinners.
All the nice things.
So
there's also journals.
Mm-hmm.
And I know that you've been asked to have a look over a few journals and places and overviews of stuff. Can you?
So one of the main outputs for researchers, and especially for astrophysicists, is to publish our results in scientific journals. And there are different ones, but there's a pretty stable list of journals with a good reputation. And what they all have in common is a peer review process. What we want to ensure is that if an article gets published, it is trustworthy. And you can imagine the difficulty of doing this. For example, the simulations and the work I've done with my group of collaborators, there's hardly anybody else in the world who does exactly the same thing. So there's one other person who runs very similar simulations, and he's part of the crowd. Right? He's part of our team. Right? So who's going to check whether we did it right or not? And the same is true for any other specialized topic, that it's not an easy thing to find somebody who can give an educated opinion whether the stuff the people claim in the article is sensible or correct or not. So the solution that has been found and has been done for probably decades is what's called peer review process. So some experienced people in the field are asked to be editors of these journals, and when an article comes in, they take a quick look and think about who in the field of the experienced people could be a possible reviewer for this article.
So for numerical modelling, it would just be somebody who's done modelling in the past, even if it's not exactly on that particular type.
It's probably not only the technical aspects, but the scientific aspects. So for example, I have reviewed both simulation papers and observation papers, and it's usually an anonymous process unless the reviewer decides to, say, reveal who they are. Right? And so sometimes I've done this, sometimes I haven't. So the editor tries to find a knowledgeable person who could comment on the article, and then they send you an email and you say, yeah, I can do it, I have time to do it. And then you read the article and write a report and say, okay, this bit needs to be explained a bit clearer. And there is a mistake in the logic in this part. So can you please rewrite this and rethink this? I have a concern that this can't quite add up. And then so usually you get something like 4 weeks to do that, because everybody is very busy. Right? So it doesn't take 4 weeks to review an article. It probably takes a day or two if you want to do it very carefully. And but you just need to find that time in, say, a 4-week window. And then you send back the report, and the authors receive that report. So that's then exciting moment, when you've submitted an article and you get back the referee report. You take a deep breath and say, okay, let's see what they say. And it usually starts off with formal part where they say, I am sending you the reviewer's report, and the reviewer has said the article needs, fingers crossed, moderate revision. If it's major revision, then I don't think I've ever had that, but moderate is normal. And then it can be anything from this long. I think the longest I ever had was 7 pages. So there was somebody real detailed. And it can be from substantial comments where you go, oh damn, I made a mistake, this needs fixing, all the way to, there are lots of little places where you can improve the figures, improve the tables, and improve how you phrase things. And how detailed that is depends on the reviewer.
Right. So how long does it usually take to get from an article you've written to get it into the journal then? It's taking like 4 weeks for a review.
Well, it depends. So when you're ready to submit your article, then the review or the first report shouldn't take much longer than 4 to 6 weeks. It might be that nowadays the reviewer even gets told you have 3 weeks. But quite often it happens, and it has happened to me, that the reviewer says, I am really sorry, I want to do it, I haven't gotten to it yet, I need another 2 weeks. And then instead of hunting for a new one, if you think you have a knowledgeable reviewer, it just takes 5 weeks instead of 3. But usually within 6 weeks, you get your report back. And then you can react to it quickly as you can, if you want to. And if it's just minor corrections, you can do them in a day or in a week or so. And I haven't seen it that often that there's another reply from the reviewer. So at least so far that has helped. That was okay for me. So I sent my second version in. They say, yeah, fine. And then comes the next step. The article then goes, well, in the early days, it went into print. And of course, it's not printed always anymore. But every journal has a very specific layout, and there's the layout editor going over it, doing the fine touches. And then you get what's called the page proofs. This is what in the early days would have been printed, and probably not all journals print anymore, but the final version is made. You get this back, and by that time, you absolutely hate rereading it. And then you have to bless that. And sometimes they have a number of questions. And so they said, okay, we re-edited this equation to make it look aesthetic. Is it still correct? And then you have to take them all off and send them off. So, but yet the longest part of getting a paper published is not the review process. It's the bit before. So at least from my experience, I'm usually writing papers with a good number of co-authors. So the first step is that I write the paper, and if it's one of my PhD students, or if possible, even undergrad project students, we would write the paper between us and bounce back and forth the paper between the student and me, or if it's just me, I'm writing many versions before I'm showing them to anybody else. And I've done papers where I've had, I'm keeping backups after a day's work or so, or I've changed something that I think I don't want to do again. And I've had papers with 30 or 40 versions. And then they go, when I think, and say the PhD student thinks the paper is okay, we send it to our external collaborators or also internal collaborators. And then they send comments. And if you have 5 or 10 collaborators on the paper, you might get 5 or 10 sets of comments. And these need to go in and be discussed, and things changed, something maybe redone or extended. And then eventually the whole team agrees, okay, that's what we're going to submit. And then that's the process.
So it's a lot of work beforehand, before the peer review,
Yeah.
so that it's only one lot of peer reviewing.
Yeah, at least that's the way I've always done it. And all the colleagues I've worked with are doing it that way, that ideally you get back only minor corrections. So you don't want a report back which says, this really doesn't make sense. And maybe that also explains why by the time you get the page proofs, you just can't see it anymore. And you just don't want to look at it anymore.
Redone it like hundreds of times.
Virtually hundreds of times, yeah. But in the end, you can be proud of it. If you've gone through the whole process and all your collaborators are happy with the work and the reviewer is happy, and then the paper gets cited and you get asked from other colleagues and say, oh, can you explain these bits a bit more? So then, for me, it's the feeling of contributed something for the community, for the field. And
feeling like you've helped people.
Yeah. Now, it's a scary thing too, because somebody might rely on what you've written in that paper. So I know that scared me a lot when I did my MSc project. Well, oh my gosh, somebody might rely on this. No pressure.
Anyway, I think we'll go to the questions from the community.
Okay.
Right. So our first question, just to wrap up for this interview, is from Ali Ma, and she asks, why do you think women are underrepresented in physics, and how can more girls and young women be encouraged to study and partake in physics?
Yeah, that's a wide field and important one, and a tough question. And my personal view is, in the meantime, it's a mix of many things that contribute to the situation. And in my personal view, it starts when you enter a toy shop. At one glance, you can see what's the girls section and what's not. It's maybe getting better, but at least a few years ago, when my son was still little, it was very obvious. Yeah. So why, as a society, are we doing this distinction? And maybe the strongest thing we are battling now in terms of any underrepresented group is the phenomenon of the leaky pipeline. So I didn't know this term until a while ago, but it describes that at no stage in the process there's a huge advantage or disadvantage for anybody. But if you think about it, you have to choose the right GCSE subjects, you have to choose the right A levels, you have to choose the degree, and dare to do physics. You have to get the same support in studying, you have to get the same support in your final year project. Then there's the PhD, then there's postdoc, then there's another postdoc, and maybe you get a temporary position, you get you get a permanent position, and then there's lecturers, senior lecturer, reader, professor. And if each of these steps, there's a 5% disadvantage, you can multiply them up. And
it's
I
like
think
unintentional bias, and it's
I think most people really don't have the intention to disadvantage anybody, but we're all human and work by quick decisions more often than we are aware of, and that's where the biases come in. And there are websites where you can test these things, and nobody comes out without a bias. And it's the hard thing, because if you don't even know you're biased, then how do you fix this? Yeah, so I don't know how well known this is in the student community, but there has been serious research in trying to find out whether this bias exists or not. And for example, papers have been sent out to, 100 reviewers or so, with John Smith, Jane Smith, and Jay Smith. And apparently the result was Jane Smith got not so successful reviews than John got. And what really struck me was when the speaker in a talk where I heard this story, when she said, when the reviewers got Jay Smith and didn't like the paper and criticized it heavily, they got asked and they said whether they think it's a man or a woman. They said, yeah, it's a woman hiding behind the initials. Right? And that hurts.
Yeah.
And it's not just been done in sciences. So I think there have been studies in music, in hiring musicians for orchestras. And as soon as you have a curtain and the committee who hires doesn't see who's playing, you get the same fraction of women among the people who get hired than among the applicants. But if there's no curtain, if there's no curtain.
They did do a review where they found that if someone did discover they had a bias, it usually meant that they were less biased from that point on.
I think we can learn. Yeah, so we can learn and we can overcome the bias, but it's tough work for everybody.
Yeah.
And I think there's no use lying about it. It would take probably another few generations. That would be my guess. So for all the girls and young women, hang in there. And even if it won't work out for our generations, let's help the future generations. I think lack of role models is another thing. Right? So I remember quite vividly when I had my son, I realized I hardly knew any woman in science with children. And the fun thing was, the ones I found, they were all married to astronomers. So I think that's changing too, but it's a long process. I think if you look back, we've come a huge way from, say, 100 years ago. Right? But the last bits will take another long time, but we need to keep going.
I know you're part of the Aurora Leadership Training.
That is an UK-wide initiative to address the underrepresentation of women in higher education. And the university offered me and kind of asked me to go and do this training. It was good in parts, but otherwise it's the fix the women instead of fix the system. So I have, if I'm honest, I have very mixed feelings about it.
Right.
Okay, but I tried.
So you'd say, is it a step in the right direction, or is it more just?
Hard to tell. Probably a bit of both. The intention definitely is the right one, and I could easily imagine that there's a number of participants there, a good fraction, who found it very useful, and there are others who don't find it useful. But then you women are not all the same.
Right. I'll go on to the next question,
Okay.
which is from our very own Alex, our Supreme Leader of the Physics Society. All hail. No, and it was, what is the best place to go to in Hull?
Oh, okay. So I've been here only 5 years, and I've had a pretty busy life, and I'm not much the pub goer. So I've visited some of the attractions, and say if you are into nature museums and so on, the Deep is a nice place to go. And if you have younger siblings or even kids, I could watch the sharks go in circles for a long time, and the stingrays are even more fun. And if you go in that one corner, you can see them sleeping on some ledge somewhere. So that I thought quite interesting.
It's and it's a year-long ticket, I think.
Yeah, you can register and then you can go as often as you like in the year. I've tried the art museum in our university library a few times, and there are some nice pictures in there. And what I also really like is that you don't need to go or drive or cycle far, and you can feel like you're out in the wilderness. Now, for example, just out of Cottingham, which is one village down from Hull, when you go into the fields, and there are even some really like fairy tale forests there. And if you go maybe towards Beverley or so, you can be out in the fields in half an hour and enjoy some fresh air and nature.
Honestly, when I started, I'm from a very rural area, and going from Cottingham to Hull on the bus and just seeing like a field was quite comforting, actually.
Yeah.
Yeah. So, right, and our final and most important question from Goro.
Okay, so I'll brace myself.
Yeah. Do you think pineapple should go on pizzas?
Well, that's a question of taste, right? And different opinions are allowed in that. But it's been a classic in Germany with ham and pineapple. That's a classic combination. And I have a close family member whose favorite pizza recipe is you get a pizza with salami sausage. I think salami is the English term as well. Pineapple, peppers, and sweet corn.
Wow.
That's pretty good.
Right. Well, thank you very much for coming on here. It's been really interesting, and looking forward to
Thank you very much. Okay, yeah, all the best to everybody for the studies, and yeah, always know we are here to help you, like COVID or not, we're here to help you. Okay, see you. Bye. Yeah, I mean, I spent some time before working out where I'm going to sit and fixing the background.
The background looks really good. Did you put them shelves up yourself?
Yeah, so we have these are IKEA kitchen shelves, but my son fell in love with them, and I said, okay, let's get them. And I even bought the big drill, and we drilled all the holes and put them all up, and we have 4 more in this room.
I thought I recognised the chest of.
Yeah, that one. Yeah. Do you know IKEA hacks? So if you like IKEA, so I've glued some wrapping paper on it to make it look nicer and put the little handles on. So it's.
I've been looking for those handles actually because I was going to get some for
Amazon.
mine.
So they usually look like this, and I just turned them around and put the handles on.
No, I've been looking for handles like that, and I've been looking everywhere, and I just can't find them cheaply.
I don't remember what they cost anymore, but I would say they were decent on Amazon.
Yeah, I'll have a look.